Bum 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 bum. Bum 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 bum. I love Army Men. The greatest game ever as a kid. So sweet. So many battles. I remember when I used to only have green ones. Then they came out with these tan ones. I wonder, how many of these guys are wearing helmets or hats? Let's see. Well, this guy right here, he's not wearing a hat. Let's see over here. What about the green guys? This guy's not wearing a hat. Today we're going to talk about conditional probability. And me trying to figure out which ones have hats and which ones don't is an example of conditional probability. Because I could divide these two groups of Army men into the different colors, tan and green. Okay? And conditional probability is saying, given that an object falls into a certain category, say the green guys, what's the probability that they have a hat on? And that would be different than saying, given that they fall into the tan group, what's the probability that they don't have a hat on? Okay? And so conditional probability is setting things into two distinct groups. And so what we are going to do today is we are going to spend some time talking about dividing things into groups and evaluating probability based on the difference in the groups. Okay? So let's go. Let's talk about conditional probability. Alright, today we're going to talk about conditional probability. And just like you saw in the intro with those Army men that were designated into two specific groups, conditional probability has to do with probability that has conditions on it, or things that are from a specific group or a specific classification. So let's start talking. Conditional probability. In this example, we're talking about vaccinated and non-vaccinated people who get the flu or don't get the flu. What we see here is we have this vaccinated line that says how many people got the flu, how many did not get the flu, the total number of vaccinated people. And in this one there's no vaccine, who got the flu, who did not get the flu, total, and then the totals of all those. What we're doing when we're doing conditional probability is we're asking specific questions based on criteria. So in the first question we're saying, what's the probability that a randomly chosen person has the flu? We're saying out of those surveyed or out of those kept track of. So we're going to be out of the total of everybody, 490. Okay? Of those, how many got the flu? Well, 97 of them got the flu. We haven't put any other conditions on it other than the fact that they need to have the flu and be from our sample set. When we convert this to a percentage, what we would say is that would be 0.198, or there's a 19.8% chance that that person gets the flu, regardless of what they did as far as vaccine or not vaccine. The conditional. This is where the conditional probability comes in. What's the probability that the person has the flu given that they were vaccinated? That qualifier allows us to separate our group. So now, what it's out of, we would say this is flu given vaccine. So given that they had the vaccine. Well, the total for the vaccinated is only 219. So that's what's going to go down here. So out of 219, how many of them got the flu? Well, really, if we look at it, it's only 21 out of 219. If we look at what that means for us in terms of a percentage, it's really only 0.096 or 9.6%. Researchers would use this to compare and they'd say, does the probability of getting the flu go down if you're vaccinated? Well, it would seem so in this small sample set because you only have a 10% chance of getting the flu compared to a 20% chance thereabouts overall. Okay? So, a notation thing. When we're talking about conditional probability, we would say it would be the probability of B given that A, and I'll write this out. And what this means is the probability that something happens given that it has this condition, or A. Okay? It's calculated using this. You take the probability of A and B happening, and you put it over the probability of A, or the number of outcomes from A. Well, what this means is the probability of A and B happening together. So that would be flu and vaccine. And from the previous example, the probability of A would be the probability of vaccine. Okay? We'll see how this looks mathematically in just a minute. Let's talk about another way to write this. If I were to divide my subsets up so that they represented various populations of this bigger proportion, so it would be parts of our sample set of everyone that was vaccinated or not, what we could say was that S would be everyone in the test, and V would be those vaccinated. And so F would be those with the flu. And the way we calculate this is we're really looking at F and V. This really means and. Okay? Because this and here is giving us the combination of those two events, not to be confused with the combination that we've been talking about. But we want F and V to happen. We want the flu and vaccinated. Okay, because we want both of those things to happen. Well, what we have is we want the probability of F given that V. What that means for us is the probability of F and V over the probability of V. Well, the probability that they were vaccinated is 219 out of 490. The probability that they got the flu and they were vaccinated is 21 out of 490. Okay? Because there were 490 total, and what that represents is a fraction of the number of people total, 490, and if they got vaccinated and they had the flu, they're in that one little upper quadrant that's just 21 people. And so this fraction really is represented by 21 over 219. Okay? So this is the probability that they have the flu and they got vaccinated. That's how conditional probability works. It's taking a subset of a larger group and saying what's the probability within that smaller set. Okay guys, so thanks for watching. We'll see you next time. Keep up with these videos because it's going to be very important that we not lose track of where we're at. Okay? So, thanks for watching. We'll see you next time.